Hello and welcome to E2 Learning Nepal. Let's take a look at this question today. So this question is related to the principle of conservation of momentum and the theory behind the perfectly elastic collisions. The principle of conservation of momentum simply states that the total momentum before and after a collision is conserved, and perfectly elastic collisions are simply the collisions where the total kinetic energy before and after are equal. So for any two given equal masses, it's stated that in a perfectly elastic collision between equal masses of two bodies, velocities exchange on impact. The relative velocity of two bodies after impact is equal and opposite to the relative velocity of two bodies before impact. It does not necessarily have to be object of equal masses. You can achieve the same thing with objects of different masses as well. There's a separate proof that I've done that you can review later on, and I'm going to make a separate video on this. But what we need to understand right now is simply that the relative velocity of two bodies after impact must be equal and opposite to the relative velocity of two bodies before impact. So let's check the relative velocities before impact. So here we can see that P is approaching Q with a velocity of 1.3 meter per second, and Q is approaching P with a velocity of 0.5 meter per second. So the total relative velocity of approach is 1.3 plus 0.5, which would be 1.8 meter per second. So all we have to figure out is find one of the options in which the relative velocity of departure is 1.8 meter per second. So what do we mean by that? As the statement suggests that the relative velocity of two bodies after impact is equal but must be opposite. That means before P and Q were approaching each other, after the collision has happened, they must departure from one another with the same relative velocity. So we can see here that out of only option D is where this criteria is met. P is running away from Q at 0.5 and Q is running away from P at 1.3. So together they are running away from each other at the speed of 1.8 meter per second. So our correct answer would be D.